Okay, so coming towards the column type of the table. So these are basically data. These include data where the x-axis consists of categorical variables or individual groups. And then so x contains the categorical variables and individual groups, and these these type of tables are used for bar graphs, column graphs, and dot plots mainly. And they are commonly used in experiments involving multiple groups or conditions, like comparing treatment effects, etc. So here you can see column tables have one grouping variable, each with each group defined by a column. So here you have control group and then treated group. And then again you will be having these similar options like XY, and you can select from these and you can paste your data. So as I mentioned earlier in the start, that it all depends on your data and you have to sort which type of table you want to select. So next, coming towards the grouped tables. So group tables are allowed for two grouping variables, for example treatment and time. And then these are suitable for two-way ANOVA tests, which is a very commonly used statistical test, and then repeated Meyer's ANOVA and the comparison of multiple groups under different conditions. And they are often used in time course or dose response studies involving multiple conditions. So in column there were two main columns, and in this there are multiple variables or multiple columns, and they can be grouped. So for example, in this example you have control, and in control you have three triplicates, and then there is treated and you have three triplicates, and then on the you can say x-axis, on the other hand, yes, x-axis you have two other groups as well. These are categorical variables. And again similarly you have the options below where you can select two or more than two groups, or the triplicates or replicates you want to select for each group. So next, coming towards contingency tables. So contingency tables organize data into rows and columns for categorical data. Each row defines a treatment or exposure, and each column defines an outcome, and each value is an exact count of objects or events. So for example, A, you have cases, and then B, you have control, and then in this case it is obvious that we have divided into separate groups, or smoked is a one group and never smoked is another group, and each case is the exact count of objects. Okay, so yes, the contingency is like this, and you can start with an empty data table or import your data. And similarly, other tables are not very commonly used. The first four are very commonly used, but these you can check out these and explore one of these options. So there are survival, in which each row tabulates the survival or sensor time of a subject. So basically it involves the time period. And then parts of whole, you can make pie charts from these, and in this row each defines in this table each row defines a mutually exclusive category. So yes, you can make pie charts or obvious data you can make from this table. And then there are multiple variables, obvious from the name. Each column represents a different variable, each row represents a different individual or experimental unit. And then there is a nested data tables, and this is the hierarchical or nested is a data design when each treatment was tested in experimental replicates, and each experiment replicate was assessed a number of times, technical replicates. So in experiments and research, you have biological replicates or experimental replicates, in which you repeat the experiment in the same situation 3 times or multiple times, and then the same experiment is repeated in another time zone, another time, which is known as technical replicates, so that you can check the results if they are so that you can assure that results are not by chance. So this nested data tables are for those kind of replicates. So yes, this was all from the start of the Graphpad Prism, and we can start with the XY table, and let's jump into it, and we can see that how we can enter our data in this graph, or we can say that, or we can start with column. So let's begin.